Greetings, friends. This is a short little video on correlations. Um, as we've said a number of times in class, correlations are one of the more basic kinds of stats that you'll run into in doing educational research. And remember that correlations are the differences between variables. We've contrasted that with other types of statistics, which are differences between groups. So a t-test and an ANOVA are the differences between groups, and correlations are the differences between variables. What you'll see when you see people discuss correlations, you'll see this name, Carl Pearson. He's the popularization of various kinds of correlation statistical formulas that we use all the time. You'll see his name mentioned in conjunction with various kinds of correlation. You'll see the Pearson correlation coefficient, which is a number between -1 and +1 that discusses or indicates the strength of a relationship. You also see it discussed as or indicated as the Pearson product moment correlation. What basically correlations are the descriptions of the relationship between two variables. That means predicting a change in one variable by observing a change in another variable. We'll show you some examples here in a moment, but basically that relationship can be graphed. And simple kind of a graph that you learned way back in freshman algebra where you plot the change on an x and a y axis. And basically what you're identifying is the change in one variable when another variable changes. So for example, there's a relationship between skipping breakfast and obesity. We know that people who skip breakfasts oftentimes are way more than people who don't. Now that's an interesting variable, interesting statistic um, that we have observed. Now we don't know exactly why. We don't know exactly why skipping breakfasts would lead to somebody being a bit overweight. You would think just the opposite would be true, but it may be because they skip breakfast, that they overeat during the rest of the day, or maybe this is an indication of unhealthy lifestyle, or could be a number of different reasons for that. So we don't exactly know why that's the case. All we know is that there's some kind of a relationship. And that's why we say there's a difference between causality and correlation. We don't know if one change in one variable causes a change in the other variable. All we know is that the two are associated. But what we are interested in is those variables that can predict an outcome, so that we know that when a change in one variable causes another. So we are interested in the more causal kind of relationships. For example, we know that an increase in time spent on the internet will cause an increase in feelings of isolation. We also know that if the more cigarettes you smoke during the day, the shorter your life expectancy will be after the age of 50. Now, these are two variables where we know that there exists causality between one and the other. Now, notice on the line on the left that line goes up. The feelings of isolation goes up the more time you spend on the internet. And on the right-hand side, we know that life expectancy goes down. Even though the relationship in the first case is positive, change in one increases the other variable, it's still a correlation, even though the change in the other causes a decrease in the variable. We also know that the time spent in preparing for a test will increase test scores. And from the field of teacher education, we know that an increased amount of time spent with a highly qualified mentor will increase the success that a teacher has in the teaching profession. Now, there are ways to make, as we've indicated, make these correlations visible. But in doing so, you won't have a simple kind of a line like we just showed. In this correlation, you'll see that the lines scatter and don't form a perfect line. What you'll see when we graph a line, what you'll see is what's called best fit. What line comes closest to predicting where a variable will fall when there's a change in one and resulting change in another. So we go ahead and draw a singular line only to show on average how that change works. Here's some other examples. The one on the upper left-hand corner is a positive linear relationship. That means on average a change in one will cause an increase in a change in the other. The one on the right, upper right, is one related to indicated by the one that we did with the smoking example. If on the left-hand side there was that graph to the number of cigarettes a day that a person smoked, and the one on the right line on the bottom, the bottom line, the x-axis would number of years of life. You can see that more smoking per day, the less number of years a person lives. There are other kinds of correlations as well that can be graphed that are beyond the scope of our investigation here. Now, when a relationship is numerically indicated, the strength of association is between a -1 and a +1. Now, the closer that you get to 1, the stronger the relationship is. We actually use that terminology. We say something has a 1-to-1 correlation. That means a change in one automatically causes the same amount of change in the other. Now, for our purposes, we very seldom see something that strong. So what we'll do is we'll see a relationship that can be indicated by a negative or positive 0 to 3. And a 0 to 3 relationship is very, very strong, slight, may not even be all that significant unless you have a large group that you're talking about. From a 0.3 to a 0.6 is a moderate correlation, and a 0.6 and above is a strong correlation. What we'll show you in a separate SPSS video is exactly how to conduct these correlations. So that's basically it in a nutshell. I know it's very brief, and again, just to refresh your memory, but hope this is helpful. And the other video will have the actual instructions on how to use SPSS to conduct the correlation test.